Office Hours Arbitrage number 5. Today I've got Boar, one of our top users, and another OG from the tournament. And I was going to start out with a nice friendly interview, and then he's got a presentation for us and some things that he's been doing. Really excited to see that. But Boar, I'd like to know, how did you find out about Numerai?
So I don't remember actually. I was just looking for a way to do some machine learning and find something to do while trying to learn machine learning. I've no clue. I knew about Kaggle before, but I have no clue how I came to Numerai. But yeah, it worked. When I joined, it was still when they had like this counter going on. The moment you submit, you would see how much money you would make, until people figured out that they could just scrape the test data by looking at the rate at which the counter was going up. But it was fun. But even though that the first year, I think it was like $80 I made in a year or something playing with that.
Yeah,
it was a fun time to start.
So you started participating around the time I did, I think. Do you know your start date?
I can just look it up. It's the June 2016.
Oh, I got you. All right. April 26th. I'm still waiting to interview somebody who's started earlier than I did. But tell me, Bor, where do you live?
Right now in Norway.
Norway, okay. Is that where you're from originally?
No, I'm from the Netherlands, so a bit more south. Yeah.
Great. What do you do for a living?
Modeling pandemics. So
Are you serious?
Yeah.
That's your job? Like that's what you were doing prior to 4 months ago?
I'm still doing that. I've been doing that for the last 10 years or so. So
that's amazing. Okay, halt the interview. What the heck is going on then? Give us some insights.
Let's see if there's some insights. Yeah, people that are not epidemiologists don't really have a good idea what's going on, except doctors know what's going on in the hospital. They just see the pressure there. But just because you're a medical doctor doesn't really know that you can time or understand the pandemic right. Like this delay between picking up the first case and what's happening in your community and stuff like that. And there's been people working on influenza every time. All these, basically everybody who did disease modeling is now jumping on this disease. So you see a ton of people that are very, very good working on this.
Mm-hmm, mm-hmm. Well, that's just an unbelievable coincidence. Those just joining, Board just enlightened me and said that what he does for a living is model pandemics. And it kind of just totally blew my mind. I had to take a second there and talk about that. That's absolutely wild. What programming language do you use and why?
Clojure. It's Lisp. I think it's about 10 years old now or something. I was programming Ruby before, and I needed something that was faster for one of the models I was doing during my PhD. And I was using Ruby when I came from C, but then I had to do a lot of text processing for my PhD. And I didn't want to use the C string libraries or something. And Ruby was very nice for just doing that, more like Python.
Oh, that's pretty unique choice.
Yeah, then I was, sort of, at that time, both Python and Ruby were new, and I sort of just picked one that fitted easier to my mind. Yeah, I like the language. The syntax is just open a bracket, function arguments, close bracket. That's the only syntax you have, basically. So I like that.
So next question, can you tell us your top 3 tips for the tournament?
Don't just focus on the actual technique that is doing the model fit, but spend time on basically documenting what you're doing so that you can keep track of all your models, and spend time on trying to evaluate your models. And now we have 10 accounts. We actually keep some of the models running longer, because you can learn some stuff from that. And the third tip would be, it's very hard to learn something from like 2 or 3 weeks of model run and then live scores. That might just be one period. So be careful there.
Who's your favorite team member?
Slyfox right now.
There's a vote for somebody. He finally put his words out, and we got a fist pump from the Slies to Foxes. Good game, good game. What's your number 1 feature, request, or improvement for the tournament?
So there's been a lot of improvements lately, actually.
Indeed.
The not having to log in and out of accounts will be nice. So that when the multi-account thing is coming.
Yep,
just,
Sam.
but I'm already happy with the one that went live just yesterday or something. With I had to fill in these features. I'll show you later on. So the daily scores are moving up and down so much. Yeah, everybody probably knows that. And then these Thursdays were sort of a random lock-in moment where you got paid or punished for it, and that felt weird. So I'm happy that we're now back on the just basically scored on the live data in the final score.
Mm-hmm, mm-hmm. And are you up to 10 models now?
3. I'm 4.
Okay. Yeah, you've been pretty busy.
So, yeah, also that. But also this is also something I basically learned. I've been doing this, not this kind of modeling, but different kind of modeling for a long time. And what you see all these new students do is they run like 50, 60 different models and look at 5 of them, and then decide to iterate again and then take up to half the cluster again because they run 50 different variants, but only look at 5 of the outcomes before they already see that they have to change something. So I'm trying to be a bit slower in changing, also because I keep track of what I'm doing. If you do a lot of things very fast, you also build up more documentation you have to write down. So keep the pace a bit slower than just try to fill up everything immediately.
That's excellent advice, and I actually think I need to incorporate that into my PhD work because I got so many regressions running right now. It's blowing my mind. So thank you. Yeah, maybe I need to slow down a little bit. That's it. Actually, very good advice. And so thank you for that. One thing I'll tell the audience, Bor and I have been speaking for a couple of weeks now. I've been trying to get him on. I asked him if he could present some of his findings on the era similarity stuff that we always see in Rocket Chat. So Bor, if you're ready, you can go ahead and share your screen and take it away.
Good. So pretty pictures, extension of clustering similar areas. And so I've been spamming Rocket Chat a little bit with things like this, and I can take some time to explain what it actually is that you see here. And so we start. Okay, what am I doing? So one of the original questions we had was which of our training areas are similar to the live data? It's obviously relevant because we've been complaining / speculating that the live data doesn't match well with the training area, so you're training for something that's not live anymore. But so I wanted to see a bit more if that is right or not. And of course, if you can make a subset of the training areas and say, okay, these are actually the relevant areas, that is an advantage to have. So how do you cluster areas into similarity? And we've been trying this for a while, and especially when back in the days where we were scored on testing areas, which was a bad idea because there was so much effort from the community just going into this. Okay, let's try to find what is the closest training area to this testing area and try to sort of hack the tournament in that way. So luckily Numerai changed to live areas. I think that was one of the most important changes they made. So what do we have? You can cluster on summary characteristics like the average score of something of the features, of the average score of the target or something in the areas. Although average score of the target wouldn't work for live data, but Numerai cleans up the data pretty well. So you're looking at really, really small differences. You can look at basically use high dimensional cluster techniques, like every feature is 1 dimension and just let it go in cluster and reduce it back to 2 dimensions, the whole thing. It was maybe easier when we just had 20 features to worry about, but now we have 310. And we were all doing basically the same thing, I guess. We were using TSNE back then. Actually, it worked, but it's a long story. And I'll not go into that, that will take too long. And I was doing some clustering based on model score. So rather than take a feature or something, I would say the performance of a single model on this, in its ability to predict for this area is what I use as one axis. And then if you have a few models, you have a few axes to cluster on. So that was where it sort of was coming from, that I was doing this, using a model score as a way to cluster areas. And I was trying to figure out, okay, I can make different models by training different subset of areas. And then I kept going from 1 to 2 to 5 different areas. And then eventually it coalesced back to just two different groups of errors. But I think I was playing with this for a year almost. But whatever method you use, some errors are more like you can, if you fit your model basically to one error, you'll find that there will be a few other errors that you're pretty good at predicting as well with this overfitted model. But you'll also be very bad on some other of the errors. So there's this thing that some errors are just, and it might just be the linear part of it, that a linear overfit works well in one error and then works in some of the errors as well, and then it really works poorly for the other errors. But then I have these two models, performance on model 1 that I call good times, and performance on model 2, bad times. And I just sort of plot for, what you see here are the round numbers for some live rounds. And this is basically saying round 190 scored pretty well on good times and pretty poorly on the bad times model. The models are called good times and bad times because with bad times, most of you guys are burning, and with good times, most of you are earning. So that's sort of, we refer earlier thinking that's just when the market's going up or when it's going down, but that might be more complicated. And then we had some discussion on the forum already, and Michael Oliver pointed out that if your two models are close to being opposite in whatever way, like P1 minus P it's called, by default you will get a diagonal that's like this. If your two models are the same, you'll get a diagonal that goes the other way around. So basically, maybe I'm just plotting on one axis after all. If you would just, let me say, I think that these two models that I'm using are actually quite close to P1 minus P.
Sure looks like it to me.
Yeah, but they're both trained on 18 errors, just a subset of 18 errors, two different groups of that. And for some reason, that is P1 minus P. I don't know why. So, and then, okay, now you have all the train and validation errors. These are the orange dots. And blue is where the live errors from up to now. I think from almost the start of Katsuguchi, I missed the first few weeks up to now. But from this, even though it's more or less one axis because it's P1 minus P, the live errors are still fitting quite close into what the orange errors are. There's some errors like this that are sort of a little bit more where both models do wrong for some reason, but that might just be the models. You don't really need these two groups of models that I have. You can run just any two long-running models. You can make the same plot. It will maybe not be this diagonal axis, but you will still just have two long-running models and plot your train and validation data scores for per area and plot the live scores per area. And you can make these plots. So. Another thing I was showing, which also is this spatial plotting thing, is that I was doing some fixed rank rigging, some kind of interpolation method. And it's basically, so I have dots here, and if these dots would be like scores, they would be like positive, negative, a mixture of it. And sometimes the mixture is really like red, green, red, green, red, green, and other times it's more like the whole green area and then a whole red area. So I wanted to do some interpolation, basically to interpret what is the average score in this area, what is the standard deviation of the models in a particular area. Say you have an area around 0.06 minus 0.04, and I get a few scores there. Can I sort of make an interpolation to see what is my performance of the model in that area? So this is what fixed rank rigging looks like. So it's taking your data points and trying to figure out what the spatial area is that is affected by the input from the single point in the center of these circles. And I got stuff like this out. So here you see, this is for a model that I'm running at home now. So this is just based on the training and testing and validation data. So you see this mixture of red and green dots. So this model is doing, this is basically, it's a different version of the good times model. So it's doing quite okay in this region, and it's doing quite poorly in the lower you get. And I'm trying to interpret, what do I do with this kind of information? Because I also have like the standard deviation, how consistent are the areas that are falling in this region scored like at the same average Sharpe score, I guess this is, or something.
That's amazing.
It's fun, but it's I'm still trying to figure out how to do it right and how not to do it wrong. Because the fixed creaking is also something that has quite some parameters to fill in, and but I was doing stuff like, okay, how do I? It's a little bit of risk management, I guess. So areas where I have a lot of standard deviation, so that where the interpolation isn't sure actually what the number should be. That's sort of, I can do something like plot not just the average score, which is the mu, but the average score minus like 2 standard deviations, and then see how this picture looks like. So I'm exploring that part. And then
wow.
I have one more slide, I think. Oh yeah, so this was my old Bohr 1 model, which was doing very well until I started staking high. I'm not sure how that works, but
it's like the tournament knows exactly when to inflict maximum.
Well, you're right. Your stake, it's like a slot, like this Las Vegas slot machines or something. Okay, now it's time to make to get them out. So it was doing quite well in these areas, and then a bunch of areas, live areas, came into this region where apparently my model wasn't doing that well. And I didn't, because this model was overfitted a bit, I couldn't see it from the validation. I could only see that this was happening when I started plotting the live data. So this was sort of nice. Oh yeah, I have to change something here because there's an area where I'm not doing right. And I noticed that in the scores as well, the live scores itself. Then it was sort of nice to try and visualize it also in this way. So that is more or less what I've been doing. Yes, this is the last slide I have from the visual part, but it's still, yeah, it's still work in exploration.
So I've tried a bunch of stuff kind of like this, because like you ideally want to be able to know what cluster you're going to be in live data, so you can use the appropriate model. I mean, I was able to find sort of functional clusters, like there are clusters in these functional relationships you can find, but you can't predict necessarily which one you're going to be in. Or at least I couldn't necessarily predict which one I was going to be in on live data, just given the features. Which is kind of what you need to do to be able to make this useful, because like being able to say, oh, there's these clusters of functional relationships, post hoc doesn't really help you to predict the future unless you can sort of get some probability of being in one of these clusters or the other one. And I was just, yeah, curious to hear your thoughts on that and how you might want to go about doing that.
The main thing I want to do is have my model work along the whole range of the diagonal, basically. And because some of the areas are not equally distributed, the training areas are not equally distributed across this whole space. So they're way more common in somewhere in the good times parts, like 1/3 above sort of the 1/3 above midway is where the most of the areas are. And if you're training your models without being agnostic of how this area distribution are, they sort of weighted to this good times, not extremely good times, not the bad times, but they're weighted to this good times period, because most of your areas come from this period. So I'm more thinking in that way, that I'm trying to, when I'm now feeding my models areas, a selection of areas, I try to give them areas that are spread along this whole diagonal. So not in a sort of not weighted way. So that's the way I'm using it right now.
Thank you so much, Bohr. I really appreciate you coming on and chatting. And I know that you said as much as you possibly could say without giving away the magic sauce. So I appreciate that. It's Slido time. Kino's asking a question. Kino, you always ask good questions. Thank you, by the way, for giving me stuff to talk about. I really appreciate that. Do you know when and how does Numerai actually burn our stakes? And is there a way to see this change on a weekly basis? In other words, how is it affecting circulation?
So it's not just withdrawals. It's basically whenever you make a change to your stake, then we will apply whatever changes we have currently in the database on chain. But then if you don't make any changes at all, then we'll just continue accruing payouts or burns in the database. Yeah.
Okay, that's how I thought it worked, but thanks for coming on and giving us the technicals on that. Kino, did that answer the question for you?
maybe let me just add one thing. Like, okay, so why did we move to this model? So in the past, when we had weekly stakes and then weekly payouts, weekly burns, this meant that we had to do, you know, one on-chain transaction for every user every week. And if I pay you 10 NMR and then I burn 10 next week and then I pay you 10 again, this actually, it costs us a lot of money to operate, because when we burn from you, and we don't get any of that back. When we pay, we have to pay out of our own pocket. And on top of that, we have to pay gas.
Right.
And it's just the operational complexity of that, I think, was getting really high as we scale. So when we decided to move to daily payouts, we thought to ourselves, okay, we could do this exact same thing, but daily. And then we just looked at our gas bill and I was just like, this is like almost more than what I'm paying everyone to the users. Now I'm just paying Ethereum just in gas. And I was just like, we can't do this. So, you know, we and Stefan got together and
Thanks,
to make
Stefan.
this new way of doing it. Thanks, Stefan.
Now our special guest today has a question himself. Newbie question: what kind of hedge fund is NMR? Well, one slight clarification: NMR is not a hedge fund; that's a crypto token. But Numerai is a hedge fund. So, and you're asking, is it a fundamental data-driven alpha model? Seems a good match, but what else? A calendar spread, quant, long, short? Well, we got lucky, and the actual boss is here. Richard, are you willing to answer that question? I can guess, but you're muted until you unmute yourself. So
yeah, what kind of hedge fund we are? Yeah, we're a global equity hedge fund, and driven by the machine learning models of the data science community. We've never traded anything except for equities, and so we're long, short, market neutral, country neutral, sector neutral, currency neutral, factor neutral. Really just
Pandemic neutral.
Pandemic neutral. Yeah. Just trying to find the edges that other people can't find and that aren't exposed to the same risk factors that other funds are exposed to.
well, I think that about sums it up. That was really good. Thanks, Richard. That gets asked a lot in Rocket Chat. It just comes up probably once every other week at least. Somebody asks what's going on, and they always, my students even ask, what's going on? Like, are they trading cryptocurrency? I'm like, no. So thank you. I think that clarifies it. Tom asks, is there a difference between using R or Python? Is one better than the other? I know that they should be the same, but are they? Or is one, say, faster, etc.? So Python and R, at least in terms of computation, they should come up with the same solution. It's just in the syntax and how it works on the back end. I use Python. I know a lot of people use R, and today we learned people even use Ruby. Is one better than the other? No, I don't think that anybody can say one is better than the other. They just have different uses. I teach Python to my students because I treat it a bit like a Swiss Army knife. You can do just about everything with Python. And I find that R is really good with time series data. But I actually tried to learn coding first in R. And I just realized that maybe there's more I can do with Python in a general sense. So they should, if you ask for a computation in R or in Python using the same inputs, you should expect the same output. That's just how this all works. And is one faster than the other? I think it really depends on the implementation. So if you can find a library that's been optimized in R that is not optimized in Python, then it probably will run faster. But otherwise, they should be pretty well the same. Or used to use genetic algorithms for feature selection, I think. How do we avoid overfitting when using these methods? And are these algos useful at all? Well, Bora, I welcome you back if you want to answer that one yourself.
Yeah, sure. All my models are still doing genetic algorithm. So if they're useful, board 3 is quite okay, actually. I can't tell why board 3 is quite okay, but it's doing well. But to avoid overfitting, there's like so many different ways you can do. What I'm doing is, so I have a maximum number of 200 features that it's basically an equation that these genetic algorithms are evolving. So it's at feature number 5, multiply it by 2 or subtract this and combine it with these other features. And currently I've settled on there's a penalty that's increasing the moment it gets above 200 features that it's using in some combination. And it might be like 50 times the same feature and then a few other features, whatever. It doesn't really matter. So that's the cost that you basically in your fitness function limit. It says you cannot use more than, if you cannot use more than 2 features, then you're going to be a very simple model. And if 200 is still not really overfitting that much. Other things I'm using is, so every generation only gets to see 10% of one single error. And then its fitness is determined on its performance on the last 20 errors it saw. So I just pick a random error from the group of errors I'm training on. And I do that just continuously for every generation once. So you get a Sharpe over these 20 errors. And the fitness function right now is like the Sharpe of these 20 errors minus the feature correlation of the solution. So that's sort of nicely matching with what Numerai is sort of recommending to focus on. And I think, genetic algorithm, I can basically hard code any fitness function I want in there, and this is what I can do.
Right.
There's a little bit of dropout that I'm using but that's specific to the genetic algorithm that I have. I can do a dropout in that algorithm. So yeah, you have tons of things you can do, but the easiest thing is to just have a cost function on complexity of your solutions.
So this is one of those, he said a whole lot, but he didn't really say anything. So I don't know if that answered the question, but hopefully it did. And I expect that. That's the way this tournament works. There's no advantage to collaboration. Will Numerai offer a route for non-participants to stake on participants' models for a fee paid to them and to Numerai?
Yeah, I mean, the purpose of the staking is to see if you believe in your model. And so if you're staking someone else and you've never seen any code and you don't know data science, your stake is just kind of based on maybe some leaderboard information, like, well, he's already coming 8th, therefore I'm going to stake him. So it doesn't give us very much information. If you want to hold NMR, you can do that and not be a data scientist. And I would say if you're not a data scientist, that's what you can do. But if you are a data scientist, we want to know that your stakes are meaningful and express information about your model without giving it to us.
Can you talk a bit about what feature selection and or engineering you recommend doing, please? All right, well, I can take this one. I don't do any feature engineering at all because the data is clean and they've done a really good job of smoothing out any kind of obvious relationships. Bohr mentioned in his genetic algorithm that some of the features are, say, multiplied by 2 or some combination of features. I don't do any of that. I'm a fan of Occam's razor, personally. The simple explanation is the right answer, right? But feature selection, that's very important, and that's something that I've talked about in the past. You don't want to oversample too much, and Richard actually was the one that suggested this be done. In the example predictions, the example model only looks at 10% of features in a go. And so doing a small sample of the feature space per iteration is very important and helps to control overfitting. And then, of course, treat the errors separately. So and then you ask, what's a reasonable feature exposure range? I don't know yet because that data is fairly new to us. Right now, my model that's on top has a slightly lower feature exposure than my main model does, arbitrage. And the difference is about 0.012 in terms of feature exposure. So the lower feature exposure model is now ahead of arbitrage. What are good strategies to reduce correlation with example predictions and feature exposure? Don't use the same model as the example model. That's going to give you a very different correlation. If you use XGBoost, you're going to have a very high correlation. That's pretty much it. Linear models will have very different correlations, but they'll still be pretty positive. Remember, if the example predictions are good, then you want to be correlated with it if you want to perform well. But to give MMC, you want to have some positive correlation, but not too much. So there's this interesting balance that has to occur. And I think that's going to play out in time, especially if we have yet another target to look at soon. It's that feature neutral target that's been discussed. What are good approaches to ensembles in the Numerai data set? I'd say any kind of ensemble is going to be pretty good. Averaging across, making predictions, or sorry, fitting a meta model on the predictions of other models. Yeah, there's tons of different ways of doing it. The key is still to reduce your feature exposure in whatever method you use. So the data is encrypted. Is it really homomorphic? Are some mathematical properties lost? Our models may be tricked. Is there any clue on what to avoid? Well, Richard, you're the mathematical guru that came up with the encryption scheme. So why don't we just ask you, how do you encrypt all these data points?
Yeah, the homomorphic thing comes up so much too. I think it's a cool word. In the beginning of Numerai, when we launched, I wrote this Medium post. I think the homepage said structure preserving encryption in December 2015. But our Medium post said using encryption techniques like homomorphic encryption. And then people kind of really latched on to us using precisely, the fully homomorphic encryption schemes, which I did try to do. And I had the data encrypted in this way, but it turned 1 megabyte of data into 16 gigabytes. And the data went from normal nice numbers like you look at now to very high dimensional polynomials that you had to then figure out how to operate on. So to any normal data scientist, or even expert data scientist, it would look like so weird to have these strange polynomials that you have to operate on. So I decided not to launch with that, and instead launch with just a different kind of obfuscation. It's not really encryption. Encryption kind of means there's like a key that if you had, you could unlock it, but the data is really just obfuscated. And the other important thing is there's so many phases after the raw data to the obfuscated data. So the raw data, you'd be able to understand, but in the middle, just the transform data, just the normalization stuff we try to do to clean the data is taking away a lot of the structure of the original data, but it really makes it more normal and makes errors look more alike than they would otherwise. So that does a lot too. So I think if we gave away our normalized data and didn't even do the final obfuscation step, people would still be very confused by what it was. But maybe if you were an expert who already had the exact same data, would be able to tell something.
You also ask, has Numerai ever discussed what a solution to this competition looks like? Perhaps metric thresholds, MMC2, Sortino, or Sharpe, through multiple regimes. Richard looks like he's itching to talk about it.
I mean, I think the ones right now, we don't see like a problem with them. Because it's some of the ones that are very high that are unstaked, it's always like, why are you not staking?
Exactly.
But I don't think, we've been refining what the sort of problem is, while people have been refining solutions to the problem. And so we changed the targets, and these new targets that we have out now that came out last year are an approach of like a better way of thinking about the problem. And if you can be good at these targets, you're really good. If you could be good at the previous targets, I would sometimes be like, you know what, why do I prefer this model on position 100 than the model who's coming first? And that's really bad for the tournament, because even the users can tell. They can like, yeah, I could be at the top if I wanted to make some bad model that I would never stake.
Right.
And so, yeah, and then I think what's true right now, if we think about the feature neutral targets or whatever the new targets are going to be, we want it to be like, yeah, okay, now this person is coming. He was coming 20th. Now he's coming 25th. But we actually like the person who's coming 20th now more than him. And so and that's because we've like refined the problem. But yeah, I mean, ultimately, the problem is, as people know, the live data is harder than the validation data. So if you sort of found the solution to a great validation set, that wouldn't be the whole answer. And then things like feature exposure or other clues where we're like, we've noticed, you know, that really matters, and Sharpe matters. And other things matter too, like stationarity, which we haven't talked about much, but I think is a really critical thing, where you don't have, it looks like you're kind of playing in a casino where you have a kind of memoryless process where your likelihood of winning next month isn't increased if you've won this month. As in like regimes on a thing for your model, which is sort of what you guys are talking about. There's no, you don't see a difference between a good and a bad era, kind of. Or they appear in a stationary way, not in a regime kind of way. But yeah, it's kind of open-ended, and that's why if we knew the answer, if we kind of, I don't think we'll ever really know the answer, because we knew precisely how to frame the answer, or frame the targets, frame the problem, we could then easily make just a neural net ourselves to do that. But we actually need people to figure things out and then stake a lot to prove that they believe in them. Yeah.
Yeah, thanks, Richard. So are there any rules for what Numerai can do with the Numeraire token, or can they choose freely? I would imagine they're pretty highly restricted.
Well, we did have this one post about, you know, what our plans were with Numerai.
Forgot about that.
We said that we've got this much allocated for users, this much allocated to investors. And we wouldn't want it to be like, you know, 70% of the token is owned by investors who never are going to use Numerai, or Erasure for that matter. So we think it's very important to have that. And I quite like the way our tokens look. There are a lot out in the community. There were a lot given away. And when we've sold to investors, it hasn't been too much, and it's not like, and it's often very much helped the token.
The final question came from Ant-Man. Following from John's question about a solution, given a long enough time frame, do you, asking me and Richard, think that eventually Numerai can solve the stock market? No, I don't think so. Because of regime changes, we'll never be able to model everything. For instance, who would have thought walking into the new year that we would be hit with a global pandemic? That is the kind of thing that we can't model. And every time something like that changes, we have new data. Also, we have rule changes like tick rules and stop limits and all kinds of strange stuff that doesn't even fall within the purview of the tournament that we're not really able to model ahead of time. But the very nature of what we're doing is working to make the market more efficient. And so in that sense, we are partially solving the stock market. And the very nature of acting on signals that exist shrinks the profitability of those signals. And for hedge funds, scale is one of the largest challenges that is faced. And so Richard's goal of managing all the money in the world is grand. And hopefully that works out, because then all of us will be fabulously wealthy and our models will pay out lots of Numeraire, and that is all of our goal. I'm a little over time, and I want to thank you all for joining. I'm going to call it a hard break, and we'll see you next week. Thanks, everybody.